Welcome back. Today, we are exploring a framework that bridges the largest structures in the cosmos with the absolute smallest particles in existence. For nearly a century, physics has been divided by two accurate rulebooks that refuse to work together. General relativity maps the smooth curvature of the macroscopic universe, while quantum mechanics governs the erratic, probability-driven behavior of the subatomic world. When researchers apply both sets of rules to extreme environments, like the center of a black hole or the dense origins of the Big Bang, the math breaks down. The equations yield impossible infinities, leaving us with a fractured view of reality. In his book, My Dear Universe, Nathaniel Faxon-Scherrier proposes a path forward, the Unified Quantum Gravity Framework, or UQGF. This framework argues that microscopic quantum fluctuations and macroscopic cosmic evolution are the same physical process, merely perceived from different vantage points on the scale of size. The unified quantum gravity equation integrates three concepts. First, wave function evolution tracks changing probability states. Next, quantum gravity corrections calculate how quantum fluctuations warp surrounding spacetime. Finally, the Heisenberg Uncertainty Principle introduces inherent probability into the gravity calculations. By locking these three pillars together, the equation provides a description of reality that scales from subatomic quarks to entire galactic superclusters. Applying this framework to the subatomic level changes the way we approach applied technology, particularly in quantum hardware. The math offers a method for gravitational error correction. By factoring the microgravitational pull into the behavior of delicate quantum bits, simulations suggest we could increase the stability of quantum processors by 1,000 times. At this micro layer, the framework also predicts the existence of gravitational quantum scalars, particles that would interact directly with the physical matter we already know. Physicists are currently studying unusual data patterns generated during high-energy collisions in major facilities like the ATLAS experiment. These predicted scalar particles offer a mathematical explanation for those documented anomalies. These subatomic findings suggest that gravity is an active participant in the behavior of fundamental matter, rather than just a property of massive planets. When we scale that same equation up, it provides a different perspective on the largest structures in the universe. In this model of the universe's mass-energy density, the framework calculates that the missing mass we currently label dark matter is actually the product of gravitational quantum fluctuations, matching the observed 27% density. This logic also applies to black holes. The framework proposes that the physical information of objects falling into a black hole is preserved through a process of gravitational quantum entanglement. By mathematically preserving that information, the equation suggests a way to avoid the infinite density of a physical singularity at the center. The theory also anticipates specific gravitational wave signatures echoing from cosmic strings, which observatories like the LIGO facility, shown here, are currently calibrated to detect. Bridging the math at this cosmic scale allows researchers to analyze the entire universe as a single, coherent quantum system. The transition from theory to engineering happens when the unified quantum gravity equation is applied to the deliberate manipulation of the spacetime grid. Because the equation links wave functions directly to spacetime curvature, it suggests that controlling quantum fluctuations can generate a directional gravitational field, a concept known as gravitational quantum thrust. Simulations based on this mechanism predict a specific impulse of 100,000 seconds, a massive increase over the baseline efficiency of modern chemical rockets. This level of thrust would reduce lunar missions to hours and make travel to neighboring star systems feasible within a human lifetime. On the communications side, the framework's calculations yield a 25% boost to quantum teleportation fidelity, providing the mathematical backing to transmit complex data securely over 1,000 kilometers. These advancements represent the point where humanity moves from observing gravity to actively engineering the fabric of spacetime. Ultimately, this framework demonstrates that the universe is not a collection of contradicting rules, but a continuous environment where spacetime is quantum from the ground up. Gravity is the thread linking the subatomic realm to the macroscopic void, proving that every scale of reality operates through the same process. To explore these layers further, return to MDU, and don't forget to like and subscribe.